Hello and welcome to yet another video on this channel. So in this video we are going to learn about posets. A poset is a set having a partial order on it, right? So we have got a partial order and what is meant by a partial order? A partial order is a relation which is reflexive, which is anti-symmetric and which is transitive, right? So we want to understand what is the relative position of elements of a set, and hence we define what is called a poset. Okay, now in order to visualize a particular set having a partial order defined on it, we are going to draw what is called a hash diagram. You can see the small diagram on the right hand side. I have mentioned the arrows there just for clarity. You can drop the arrows as well. But the features of this hash diagram are as follows. It has got a transitive reduction, which means that transitive relations are not included. What do I mean by that? So if you have an element a comma b and another element b comma c, then the element a comma c is not required to be put on the poset diagram, right, on the hash diagram. Okay, and also there is the other feature called the upward orientation, which means that the least number should be at the bottom and the highest number should be on top of that, right? So if you have, let's say, an element which looks like a comma b, right? Then b should be on top and a should be at the bottom, right? So the arrow should go like this. Again, you can drop the arrow, but anyhow, all right, and the the final hash diagram should be acyclic. So the hash diagram that you can see here on the right hand side is corresponding to the example given here. So 2, 4, 6, 8, 12 is a set with a partial order defined as follows: that if a comma b belongs to the relation R, then A divides B, right? So so anyhow, let's get into the example. We'll explain the example as we go ahead, right? Okay, so let's say that we have got this element uh, A which belongs to capital A. Then we know that uh, you see that an element, any number A, is basically that particular number multiplied by 1, right? So both of them are equal. So which means that A divides itself. And since A divides itself, therefore A comma A belongs to R, and hence the relation is reflexive. Correct? Okay. Now let's suppose that there is an element called A comma B in our relation, which means that A divides B by the definition, right? So A comma B belongs to the relation if A divides B. So A divides B, which means that there is an integer K such that B is equal to K multiplied by A. So for example, let's consider 2 comma 4, right? So 2 comma 4 belongs to R because 2 divides 4, right? So 2 divides 4, which means that A is equal to 2 and B is equal to 4. So now we can write this as 4 is equal to 2 multiplied by 2, right? So this 4 is B, this 2 is A, and this 2 over here is the value K. Now, since 2 divides 4, we cannot write that 4 divides k, because 4 because you see that 2 is written as half multiplied by 4, right? So 2 is again a, uh, 4 is b, but 1 by 2 is not an integer. So we cannot say that 4 divides 4 divides 2, and hence b comma a is not an element of the relation, and therefore our relation R is an anti-symmetric relation. So we have reached a conclusion over here. uh, like we were still waiting for the next property to be proved or disproved, right? So our relation is reflexive, our relation is symmetric, right? Okay, let's move on. Let's see. It is it transitive or not? Right. So let's imagine that we have got two elements a comma b and b comma c. Let's see how we can take an example over here. So let's say that our a is equal to 2, our b is equal to 6, and our c is equal to 12. Right. So a divides b. Right. A divides b because our b is 6, and the 6 can be written as 3 multiplied by 2, right? And b divides c because c is 12. 12 can be written as 2 multiplied by 6, correct? So 3 and 2, both of these are integers, right? And hence, but also we know that uh, 2 12 is 6 multiplied by 2, and 6 is also an integer, right? And you see that 3 multiplied by 2, right, is giving us 6. So basically, if we choose any two pairs of any two order pairs, right, a comma b and b comma c, we will see that it's quite evident that a comma c is going to be the element of the relation, and hence our relation is going to be transitive as well. And since our relation is reflexive, it is anti-symmetric, and it is transitive, the relation R defines what we call a partial order on the set A, right? And hence A is a poset. Now, let's draw the hash diagram over here, right? So for that, let's first write down the relation. You can see that the relation is written over here, right? So we have got elements like 2 comma 2, 2 comma 4, 2 comma 6, 2 comma 8, 2 comma 12. So 2 divides all these numbers. 4 divides 4, 4 divides 8, 4 divides 12, and hence we get these three numbers. 6 divides 6, and 6 divides 12, right? And of course, we have like 8 divides 8, and finally we have got 12 divides 12. So these are all the elements of our relation. So we start with the diagraph. What does a diagraph mean? A diagraph means that if a comma b is an element of the relation, then we will draw an arrow from a to b, right? So by that rule, the diagraph is as shown. So I have given dotted edges over here because we will remove um, some of these edges from this graph. Now, what we do is that the first rule is that we remove all the loops. Every loop we will remove. We are going to remove the loop over here. We are going to remove the loop over here, 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 and here. All these loops are going to be removed. We don't need them, right? Okay. And also, we are going to remove the reflexive elements. What does a reflexive element mean? We saw that previously, that if a comma b and b comma c are there, then this would imply that a comma c is also there in R, right? So if so what we'll do is that we are going to remove the edge a comma c, right? Okay, let's look here, right? So um, okay, so let's yeah, so let's look here. So so those are the transitive elements. uh, so what we do is that we remove this particular edge over here, which is 2 comma 8, right? So we remove 2 comma 8 because we have got 2 comma 4 and we have got 4 comma 8, right? So that is the reason we remove the 2 comma 8 as mentioned in the first rule here. The second rule says that if we have 2 comma 6 and 6 comma 12, we are going to remove 2 comma the age from 2 to 12. And once we remove all of these, we get our hash diagram. Let's so what I'll do is that I'll draw the hash diagram over here. So 2 is the edge, 2 is the vertex over down here, 4 is the vertex here, 6 is the vertex here. Both of these are at the same level, and 8 is the vertex here, and 12 is a vertex here. So only the immediate divisors of each of the elements is being mentioned over here. So this is our hash diagram. Thank you for watching. Stay tuned for more.